Okay, so here we are. I'm going to try and go over these homework problems with you so that if you do have any questions, hopefully I can answer those questions for you now. So the first problem, problem number 7, is use the formula A equals PERT to find the value after 10 years of a $1,000 investment at 6% interest, compounded continuously. So because we know it's compounded continuously, we are going to use our formula PE raised to RT. And let's see. So I could do, I'm just going to write over here. So I have, I'm going to move this up a little bit. So I know that P is my initial amount, and it is times E. My rate is 6%, and remember, when we type this in, we're going to use our caret and 0.06%, and it's compounded continuously. Compare your results with, let me see, after 10 years. Sorry, I knew that there was a 10 in there, times 10. And when we do that, I just do want to show you there is another button that we can use on our calculator, and that is located right here, and I neglected to show that to you today in class. But it is under this first left column. It says LN, so I'm going to use second LN when I want to find, when I want to use E. Okay, so I'm going to type in right here our initial problem, 1,000 times, I'm using that second LN button, which gives me, and look what it does so nicely, it gives me that parentheses, and it's going to be 0.06 times 10. I'm going to hit enter, and I should have that amount after 10 years. Okay? Sitting in the bank doing nothing for you. So that's why you want to put money in as soon as you can, because you're making money just by having it there. Okay? All right, so that takes care of problem 7. And problem 8, 9, and 10, again, are just the same problem, and I'm hoping that you're okay with those. Number 11, sorry. It says use the graphs of y equals 2x and y equals 3 to the x to help you sketch the graph of y equals e to the x. Do not use a calculator to find coordinates. Okay, so I started by making the old chart. So I know that when x is 0, y, x, so I have y equals 2 to the x. So when x is 0, I know 2 to the 0 is equal to 1. I know that when x is 1, it will be my base, whatever that number is. And in this case, I said when x is 2, I have y is 4. The next one, I'm going to do the same thing with y is equal to 3 to the x. Please note, what do they all have in common? When x is 0, my y is going to be 1, because any number to the 0 power will be 1. And when x is 1, it will always be the base, 2. In this case it was a 2, here it was a 3. Okay, and I'm going to use that, idea for when y is equal to e to the x. I know that when x is 0, y is going to be 1. When x is 1, I have 2.718, and I haven't done this part of the problem. And if I have e, I'm just going to do, let's see, second ln squared equals, I'll have what? And this will be 7. by making a chart. And I know that when x is 0, all of them are going to go through. X is 0 is going to be 1. When x is 1, it's going to be 2. When x is 3, when x is 2, sorry, I have 1, 2, 3, 4. So the graph of the first equation is going to look something like this. When I do my next equation, I'm going to have when x is 0, y is 1 as well. When x is 1, it's going to be 3. So here I have 1, 2, 3. It's going to be a little bit what? Steeper. When x is 2, it's going to be up here somewhere. What do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be approximately up here. So this graph is going to go through there as well. And I can guess then what will happen. I'm going to zoom out a second. When I have, when x is 0, y is 1, it's going to go through that. When x is 1, it's going to be 2.7. So here's my 1, 2, 3. It's going to be somewhere inside. They'll all go through there. Okay, so that should help you out in terms of graphing and how they're all related. My table, and then my graph, and my equation. All right, so that takes care of question number 11. Let's look at number 12. Okay. Number 12. I had to read this a couple of times. I'm guessing you did too. Suppose that the probability of waiting less than 10 minutes for a radio station operator to take your dedication is p to the x is equal to 1 minus and e raised to this power, where t represents the average time in minutes for the operator to take a dedication. Okay, so t is the average time for the operator to take a dedication, and x is the probability of waiting less than x minutes. Okay, so it sounds like a plug and chug to me. Operator A answers the phone in an average of 3 minutes. That must mean my t. What is the probability that the operator will answer your call within 2 minutes? Is that less than the 3 minutes? Okay, less than, so I'm going to plug that in. And let's see what I have. When I plug that in, t is the average time. You can see that I've written myself a note. T is the average time, and this is the time less than that 2 minutes. And my answer would be 0.468 or 0.487, I could say. Okay, and I believe the next one was less than the 4. And again, these are just your plugging them in. And when I did this, I didn't write this very neatly, I apologize, but remember, this is raised to that power. Okay? That was number 12. And then again, the next one was less than 7 minutes. And then they did the problem again with the average time, I believe, was 5, and if they answered less than the 2, and you would find your numbers here. So I'm hoping that at this point you understand the question. All right, number 13. Okay, number 13. I just started this, and I'm sorry, I'm not going to do the whole problem out for you, but let's just read what it says. Eraser. Jeez, some things never change, even when you guys aren't here, I can use an eraser. Okay, so saving for college. And I thought that for you, or you might think about this. Maria's parents deposit $2,500 in a savings account that pays 5.5 yearly interest, compounded continuously. Little bell should be ringing, okay? Write and graph a function that shows the growth of this money over the next 15 years. Okay, so I know what they're giving me. All right, where am I? Here we go. 2,500. It's being compounded continuously, so we're going to use E. I know that 5.5%, if I convert it into a decimal, is times 0.055, and it will depend on the time. But I've been asked to graph this to look for it. So using my calculator, I went to y equals, okay, and my calculator, oh, here it is, here's the x. So it was 0.055 times, and then the x is on the next line. And I just want to show you my window, okay? I thought, well, if they started it when she was 20, a newborn or whatever, maybe we want to see what it is before she's 18 or goes off to college. So I did x max of 20, an x scale of 2, y minimum of 0, and I thought, well, let's see how much money she has. So I went up to $10,000, and I used a scale of 5,000. 10,000, yeah. Okay, and this is what my graph looked like. So the question, I believe, was, let's see, write and graph a function that shows the growth of this money over the next 15 years. So I'm going to hit a trace, and actually I used this before, so I can see that when they deposited the money, we can see it should be back there. There we go. What is that number? X is 3. At the beginning of time, they started about when she had, they deposited the $2,500, so it's a little bit over there. And I can see that it's growing, 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 growing. And I want to know when my X is 15, how much money will she have in the bank? And when it's approximately 15, it will be, what is that? $5,738. I can always again look at my table and then see, oh yeah, when X is 15, I have about $5,707. Okay? So in 15 years' time, it did what? About doubled. Okay. So now they're asking you to make a table to compare the amount in this account after 15 years when compounding is done yearly, quarterly, monthly, and continuously. I don't have my textbook with me. I'm filming this back in our classroom, and I don't have my book with me, but I believe that should be on page 640 or thereabouts. They're asking you to do what we had done earlier when I was showing you all those different rates. So you're just going to make a table to compare the amount in this account after 15 years when compounding is done yearly, okay? And if it's done quarterly, monthly, and continuously. The only thing I'm going to remind you is you may want to use A equals P 1 plus the rate over the number of times it's being compounded times the number of times being compounded for the number of years. And we would do this when compounded is done yearly, that's not a big deal, but quarterly, monthly, and then continuously. Okay? So if you could do those and demonstrate that you can do at least A and B, you could, and see, then you are in good shape with understanding what it means to compound continuously. Okay, so happy trails, good night, bye-bye.